Hi everyone, welcome to Linear Relationships, revision lesson 2 for stage 5.1. Today we're looking at the distance between 2 points on the Cartesian plane using a range of strategies, including graphing software. So for our example, find the distance AB. So the distance between these 2 points. And you can see that I've made a right angle triangle in GeoGebra to remind you of Pythagoras' theorem. So the distance from A to B, if we square that distance, it's the same as AC squared plus BC squared. So AB squared, this line, equals AC squared, this one, plus BC squared, which is this one. So we've got 1, 2, 3 for this distance, and 1, 2, 3, 4 for this distance. So 3 squared plus 4 squared. So AB is the square root of 3 squared plus 4 squared. So AB equals 5. The alternate setting out would be this one. So I'm happy with this setting out. If that makes sense to you, you can see there's a little less working involved with this one. This is what you need to be able to do. Describe how the distance between 2 points can be calculated using Pythagoras' theorem. Next learning intention is to sketch the linear graphs using coordinates of 2 points. So for example 5, construct a table of values for the lines below and construct a graph. So if x equals 3, what does the graph look like? So x, which is this part of the graph, this axis, and y is up here. So if x equals 3, we get a point there. X equals 3, x equals 3, x equals 3. So we actually get a vertical line going through here. If x equals -1, then the points are over here. So there's a point here, point there, and we join these lines up. Using a table of values, if x equals 3, we always get 3 values up the top here. Doesn't matter what the y values are. So x equals 3 when y equals 0, when y equals 1, and the same for when x equals -1. -1, -1, -1, 0, 1, 2 for our graph. So you can see x equals 3 is this line, x equals -1 is the green line. Example 6, construct a table of values for the lines below and construct a graph. So if y equals 2, this time it's the bottom number that's always 2. Y is always 2. And for y equals -3, same kind of concept. So the graph looks like this one. Y equals 2 for the purple graph, and y equals -3 for this one. So remember, put your x and y axis on. Or 7. We need to state the equation of the x-axis and the y-axis So the x-axis is this blue line. So you'll notice with this line that the y values are always 0. So for the blue one, y always equals 0. And for the y-axis, which is the vertical line, x is always 0. This is the line for x equals 1, x equals 2, x equals 0 is this one. So you'll see x-axis, y equals 0, and for the y-axis, x equals 0. Example 8, draw the graph of these graphs. So using GeoGebra, y equals 3 minus x is this line. You'll notice that it crosses through 3, and that's not a surprise because we have 3 here. Minus x means that every time we go down one, we go across one. The gradient is minus 1. For the next one, the blue graph here, y equals x plus 1 over 2. That'll be this one. So it crosses the y-axis at 1/2 because we have 1/2 here. And the gradient for this one is actually 1/2 as well. The green one looks like this. For the green one, I like to think about what happens if x equals 0. That means y equals 5, so we get this point. If y was 0, we would get x equals 5, which is this point. X minus y equals 2, we can do the same kind of thing. When y is 0, x equals 2. So that's this point. And when x equals 0, we get minus y equals 2. So y equals minus 2. So we want you to be able to do these graphs in GeoGebra. So you should open up, or a different graphing software. GeoGebra is a good one. And you can do it with table of values as well. For the last one, y equals 2/3 x. So this one goes through x equals 0, y equals 0. And when the 2/3 tells us that when you go across 3, you go up 2. That's what the 2/3 tells us. Or you can think about go up 2 and across 3. Example 9, which line below does the point 2,1 lie on? And you can see that it's this one, a different color. So what that means is when we change x for 2, y equals 1. 3 take away 2 equals 1. You could draw the line of each of these. So draw the graph of each line. 3 minus x looks like this. And you can see that the point 2,1, so when we go across 2, up 1, we get that point. Algebraically, it looks like this, which is basically what I did over here. The x value, this one, goes here. So 3 minus 2 equals 1, which matches up to this number. So the point 2,1 lies on the line y equals 3 minus x. And it doesn't for the others. You can see here that I've substituted in the numbers. And the left-hand side doesn't equal the right-hand side for each of these. 2 plus 1 doesn't equal 5. 2 minus 1 doesn't equal 2. Example 10. Which lines below have the same gradient and are parallel? You can see the blue graphs have minus x. So the gradient is minus 1. So they have the same gradient. So that means they're parallel. When we draw the blue graphs, we get these two blue graphs. And they're parallel, which means they're the same distance apart. Y equals 2x plus 1, 2x minus 2 are the green graphs. And you can see that they're parallel as well. So they have the same gradient. The 2x part tells us that they're parallel. Okay, so this is a revision of linear relationships. If there are still things that you're stuck with, you need to have a look at the lesson series.